In this video, we're going to keep talking about matrices. Like if I've got this matrix A, and I'm trying to figure out, well, what's the size of A? Well, the size of A will return the number of rows, which in this case that's 2, and the number of columns. In this case, that's 3. So yep, sure enough, we get the answer of it's a 2 by 3 matrix. What if I want to pull out an individual item out of that array? Well, if I say something like, what is in the first row and the third column, then I'll get that number 4 back. One function that we could use with matrices is the transpose operator, and that's just a single quote, and that'll take, my original A was 2 rows and 3 columns, and that will take all the rows and turn them into columns, and all the columns and turn them into rows. So we used to have this as our first row, and now that becomes our first column. There's a few other interesting things we can use with matrices. We could use the word end, and instead of saying I want something on row 1 and column 3, I could say row 1 and then the ending column, and that would give me the same thing. What if I have my A and I say end comma end? Well, the first end means the same thing as the number 2, because there's only 2 rows, so 2 is the last row, and the other end means 3 because 3 would be the index for the last column, and that would give us this value right here. We could also use with matrices a colon, and the colon would be a placeholder for all of the rows. So if I were to say colon, all of the rows, but only the first column, then I'll get back that first column. And if I wanted the third column, I'd get back that third column of A. There's another way you can use the colon operator, and that would be to help you initialize the values in your array or matrix or vector, depending on the dimensions. So if I wanted to say I want to create X and I want it to be all the values from 0 to 100 in increments of 1, well, we wouldn't want to type out by hand all of those values. That would get really boring and time consuming. But we could use the colon operator to say start at 0 and go all the way to 100. Now this is going to scroll off my screen, but we can see that we've got something. X now goes from 1 to 100, or actually, sorry, 0 to 100. So there's actually 101 different values. So the colon operator can take an optional argument that has to do with the step. So let's say I just want the even numbers between 0 and 100. So now I'm just getting the even numbers. I'm stepping by 2 each time. We could even, let's say we want to go from 0 to 1 in increments of 0.1. And now we'll go 0, 0.1, 0.2, 0.3, etc. Notice that when I'm running these commands, I haven't so far been using a lot of semicolons at the end. If you use a semicolon, you'll suppress that output, and you've still created the variable x that has 1 or 0 through 1 in this case in increments of 0.1, but you haven't printed it to the screen. So to print things to the screen, you could either leave off the semicolon, or you could use the display command to either print numbers or character strings. Another way to print using Matlab is a command fprintf, and that's a way to combine not only a string, my age is, but to embed in that string a number. So if my age is 42, then I can go ahead and print out these characters, and then in place of the %d, I'm going to substitute the number 42 here. My age is 42. We could also print out something that has a floating point number, so decimal place. Matlab has a built-in pi, and with floating point numbers we can specify how many of those decimal places we're interested in seeing. We could also say let's say like a character, it's getting to be a really long line, we'd use %C to be the placeholder for that character, and then we could pass in the letter H, so my initial. One final command I want to tell you about with Matlab is the input command. So with the input command, we give the user the option of typing in something, and that we could store as a variable and use that later on in our program. So for instance, if I want to say age is equal to input, enter your age, then whatever you had in those quotes with the input command, that will be the prompt to the user, and then they will type in their age, and in this case 42 will be stored in the variable age, and I can see that over here in my workspace. If I run the same exact input command again and I enter in a different age, 11, then now age is 11. So the input command gives you the ability that each time you run your program, there could be different things going on, because any arithmetic you do or plotting you do with this age variable, now that's going to be different depending on the age that the person input. Maybe one more thing I could show you with the colon operator and creating arrays is plotting. So with plotting, I could say, let's say I want to plot from 0 to 2 pi in increments of pi over 10. So if I'm doing something with a built-in function like sine or cosine, then I might want to do things in multiples of pi. So let's say I want to plot the sine of x. And well, the x I created, I've got 21 different values going from 0, pi over 10, pi over 5, etc., all the way to 2 pi. And then I created a y value for each of those x values, taking the sine of x. So my y values look like that. Now to plot in Matlab, I just use the command plot and then pass in my x array and my y array, and another window will pop up with the plot of x and y. And sometimes it takes a while, sometimes it's hidden behind my window there. Oh, it took a second, and that is the plot of the sine of x.